Hi everyone. I'm quickly going to show you one context profile that we're working on internally. It's one of the official ones, and it's about Revit. So a while ago, we started a little survey, and we found that the amount of people who would like to use Rhino inside Revit with Raven was just amazingly large. So we started looking into it, and I will talk about it while you see the video in the background. It's a sped up process basically, but I started with a floor plan and sent that to Raven and basically let Raven construct a BIM model of such a floor plan, right? So first you start with the outline. You get a subdivision of the rooms, and all of that basically with wall elements natively inside Revit. They're just generated through Grasshopper. I didn't do anything within Revit. It's all from Grasshopper, and basically didn't touch Grasshopper either, so it's all Raven who did it. You can see that actually here, using the sliders, I can manipulate the geometry. It updates in Revit immediately. And yeah, it's just a super cool feature, and lets people like me who have never used Revit before this get started in Revit. Of course, it's like a very, very complex and powerful program, but for simple things, Raven works already today. There are many applications that are possible with such a powerful and complex thing like Revit. This is just like really the very, very tip of the iceberg. A very simple showcase. We're very early in this journey, but you can start creating tags, annotations, even views. So what you can see here, where the mouse is, if you see that, I created a section view, like a section view of my BIM model with Raven. I didn't know how to do that. I would certainly not know how to do that in Revit. I'm sure there's a way, and if you know it, that's great. But basically, I asked Raven to do it, and it created a plane, and on that plane, it created a section view. Yeah, you could quickly see it up here in the top right corner. This one, yeah. And then finally added the pitched roof, which was transferred as just geometry, I think. I added some windows. Of course, it's a long iterative process. First, they were stuck to the ground. But then you work with Raven, tell them, well, this needs to change, moves the windows up. There's still a few issues with windows in the corners, but generally, this is really cool. Like without any Revit knowledge and half an hour of time, I created this floor plan. This is an elevation, or no, I think that's the section. And all of that basically, yeah, in a single Grasshopper script. So that's really just the beginning, and we're going to work on this further. If you're interested in that, we'll put out new videos about this in the coming weeks and build up the context profile for Rhino inside step by step, make it more powerful and more complex, and adjust it also to the use cases that you guys need most. So if you're interested in that, stay tuned. And there will also be ways for you to bring yourself into the process and help us tailor it so that it's the most useful version of itself. So yeah, and for those who didn't know, Rhino inside Revit is basically inside Revit you open Rhino, and then there's a Grasshopper plugin that provides all the functionality in terms of components. And we didn't have to specifically train Raven. As you know, Raven just uses plugins as it finds them. So just using the component names and the descriptions and a little bit of extra context that I wrote, this was possible already. So it also shows how powerful Raven and the plugin combo is, as it even allows you to get out of Rhino and into other softwares. There are other bridges like ArchiCAD, which is quite common in Switzerland where we are, or in Germany as well. There's a bridge to Tekla structures, which is more for structural engineering. And what else? I mean, there are 1,000 plugins in the Food for Rhino. So yeah, also feel free to try them and break Raven with it, and then come back and we'll try and fix it. So with that, I'm gonna hand back to Moritz. We're gonna try and open that Rhino again, and let's hope it works this time.
So, okay, I think my Tekla license was fetched in the background in the meantime. Let's see. Look at our model. So, okay, actually it wasn't. That's all right. Tekla, I said Tekla, but I meant, of course, Karamba. Okay. So, you can see I should have a license, so I'm just going to ask this to recompute or close the model and open it again. License. Yeah, okay, I should have a license. There we go. Okay, so now you can see I have loaded this bridge model, right? It's a little bit messy because we're already running the simulation, but if I select just this part, you can see that basically we're adding a bunch of lines for this truss. Then what Karamba does, actually, let's find out what this file does by using Raven. So if we open up Raven and hope that this time it loads, here we go. Looks like all our problems are resolved, but don't jinx it. What does this file do exactly? And you'll notice that this is just normal Raven, right? Raven set to the smart mode. I don't have any specific context about Karamba loaded in just yet. I'm literally just asking straight up, what does the file do? And it's actually, I want to also design this kind of bridge with you guys, but first I want to explore, like, if you open up a file that you don't know yet. So here we get a little summary. We have a geometry input. There are boundary conditions that we're defining. Some loads, that would be the loading groups on here, it looks like. And then it's running an analysis and giving us a result. So let's ask some questions and let Raven edit this Karamba file. So for example, is this a good design? What's the analysis result? Because I might not really know, sorry for my typos, what this was supposed to simulate. If you zoom in, you can see some of the members are in compression, some are in tension, and you can kind of see a color code of how much, but I might not be a domain expert to really evaluate whether this was like good or not. And so just to get me started using Karamba, for example, I can use Raven and just query Raven. And then if we zoom in a little bit, we can see that we're constructing a model by taking the lines, turning them into beams, then applying the loads, and in the end, running the analysis. So now Raven has very powerful tools to search through the details of the script. So you can see here it says closer look, which means Raven was zooming in on some certain part, and now it can tell us here, the maximum displacement is actually 3 millimeters. For such a large span, that is, they're performing excellently here. That's what Raven says. Great. Okay, so there's also, he says, only some very basic forces applied. So there are no bending moments, no shear forces. No, actually, that's a good thing about the truss. Yeah. Great. The forces are purely axial. Great. Now I want to learn more about the beams that we have here. So I'll ask Raven, what kind of beam members do we use right now? And just to remind you, I didn't even set Raven into our Karamba profile yet, but because Raven operates on the nodes, whatever plugin you use, even if it's your own personal plugin, it can look around and look at the semantics within your file without any specific context. So now it says we're currently using circular hollow section steel tubes. And that's one kind of beam that we can use. And I guess what I will ask Raven is, can we change them? Can we change them to W beams, which is another standard beam, steel beam? And let's see what Raven does. So here you can see Raven is taking another closer look at the script. It's starting to search through the available components. It's kind of like searching through here, beams. It's doing it several times, trying to pinpoint the W beams. Yes, we can change them to an I section like W beam 2. So you need to replace the circular hollow one set. Show about the current component and set up a basic I section configuration for you. Actually, look through any beams that are available already. So I realized that currently what we're doing is making our own cross section, and then there are some UI elements here where you can change the cross section of your beams. But maybe we want to use a specific beam that is already like ready-made. So now Raven is going back to search for any like ready-made beams. Okay, great. So Raven wants to create a new cross section. Anyway, so you can see we can start to modify the script in this way. And it's cool, but the limiting part of this example is that we are actually loading in the ready-made geometry, right? So we cannot run a comparison of different designs because the design that we have is loaded in here as ready-made curves. So instead, what I will do is I will close Raven and close this file. And instead, I'm going to move to a new empty file. And I will now design a new truss bridge with Raven. So I'm going to say, let's build a truss bridge together. Start by adding frames to this deck. And now I want to take a screenshot. I will do that with the Windows screenshot, built-in like screenshot capability. And then I'm going to open the screenshot and I will just draw the kind of frames that I want Raven to start modeling on this deck. So we'll start with smaller frames that get a little bit bigger to the center and then smaller again at the end. So I'm going to add that to my clipboard and paste it in the Raven chat. Now, notice how I haven't referenced the geometry yet. And so I expect Raven will ask me to add the geometry reference before it can add any frames, because right now the canvas is blank. So the context that Raven has is 0, and it doesn't actually see the Rhino script yet. It only sees the screenshot. Obviously, this truss is going to be fairly simple because we don't have that much time especially after all the technical difficulties of the start. But you can imagine drawing, 5 different ideas for a bridge, something more complex than what I just did, or just experimenting. And I will walk you through all the way of setting up this bridge parametrically with Raven, just making the geometry, and then we're going to bring it into the Karamba analysis file to evaluate it. And because we'll have a parametric model, we can evaluate many versions of it and maybe find a more optimal one, or discuss with Raven what we need to make this a well-performing truss bridge. So sometimes Raven is thinking very, very hard, but I'm sure it'll return. In the meantime, we can go and evaluate get some more context on what we're building. So let's measure the length here. So we have a 72-meter span. We already measured 2.4 meters width. So fairly long, nice pedestrian bridge. It's actually based on an example of a real pedestrian bridge that you can evaluate many different funky designs on. So here we see Raven has returned, has a whole logic already set up, and just needs me to reference the actual deck. So here we see there's a surface component already. Raven named the deck input. By the way, if you remember, there are these floating nicknames that we've introduced, but you can now turn them on and off. So here on the display, you can turn on the nickname overlays, which are useful if you want to see exactly what Raven is naming the different components, but they're of course not necessary. So I know that I can select this deck now and right-click on that parameter and say set one surface, and now it is referenced. And I expect also Raven will return and ask me to do just that. But I don't really want to, if Raven is about to come back, I don't really want to interfere. So there we go. See, so because I referenced the surface deck, Raven was wiring it all up, and now it's ready to go, and you can see the frames have already shown up. So we have one set frame height and then a frame count. That's not exactly what I meant, but also no big problem. You can see Raven has this time a little bit of a better layout than in our Revit video. And here it has grouped the components that belong to the frames. So I'm going to prepare my next message to ask Raven, please scale the frames. Tallest in the center and lowest on the two sides. Only in one direction. So I mean, it's a fairly simple start, and I want to move on quickly. So because I know you guys have planned for this to only go until the full hour. So I'm going to prepare my next message, and I'll just say, Raven, please turn the frames into a single truss, no bracing, or actually we could also ask for no bracing yet. Might also be that a lot of people are using Raven on him right now, and it's starting to respond a little slower. So it's calling component search again. That's a good sign. Figuring out how to do this dynamic scaling. And of course, we can set the total height or the overall height. We're going to have to get new parameters here, so we can set the height of the start and the end or something like that. So Raven is looking through the available components again. And there we go. We do have, I guess, varying heights now. And now Raven fixed it. So here we go. We have the varying frame heights. I'm going to make sure we have a lot of variance here to make it a little bit more interesting. And if you zoom out a little bit, you can see the graph that Raven is evolving. And actually, I will just interrupt Raven, because that's also something you can do. Say, okay, this is fine. We're good to go here. And now I will send a new message to turn the frames into a single truss. I guess we need a little bit more minimum height. 1 meter will not be enough for our pedestrians to pass. So let me expand that to maybe 3, something that's comfortable, 3.5. If there are any questions in the chat, then also we can discuss those. So you see the process is the same again. Raven looks up nodes, figures out the best way to solve this in Grasshopper, and then we'll add those nodes to do our truss. The interesting thing, as soon as you introduce simulation into diagonal members, so I'm gonna expand, move on to the next step. It's you can see I'm using Raven really in a like step-by-step fashion. This is also, of course, a live demo, so I don't want anything to go wrong. If you break down the steps that you need Raven to do in smaller bits, you get way more reliable and predictable results. You can try to do this truss bridge in one go, and you might be successful. But if you do it step by step, it basically works every time. So I guess we can have a little chat here while Raven does the work that I, works through this workflow that I prepared. One thing that we would be interested in is what are the plugins that you guys would love to see or are interested in. So we can maybe we can show those today, or maybe we can just discuss them. That would be something that's really interesting for us. We have a Discord where we really encourage everybody to come join and tell us things like that when they want a certain plugin supported, or the plugin's already supported but not working as they intended. That would be something that we were interested in. So go ahead and go to the chat and tell us what plugins you're interested in. And in the meantime, I'm going to tell Raven to prepare this truss. I actually want to make sure that we get. Oh, we also need diagonal bracing. I think it would be good to have diagonal bracing in the top and bottom bits of the truss, not just on the sides. So let's ask Raven to do that too. Also add bracing in the top and bottom sections. And then I'm also going to prepare the next message to prepare this model for analysis, collect all lines in one curve parameter, then the 4 support points in one point parameter, all deck to truss connections, because that's where the weight of anyone walking on it will be, in one point parameter. And okay, I think that's good enough. We're gonna start somewhere. So, are there any plugins that came up?
Robots.
Robots. Yeah, very good. Cool.
Pufferfish, Weaverbird, Mesh Edit, Lunchbox, Ladybug, maybe.
Nice. So we actually used to always do Ladybug demos. We decided not to do that this time and show you something new. But Ladybug is something that we have video. Yeah, we have a specific video about Ladybug. We have a context profile as well. Tekla, cool. Yeah, we are integrated with, like, the Tekla bridge does work with Raven. It's another one of those tools that we also need the community to tell us how Raven is doing on Tekla and what is working and what isn't, because the Grasshopper community is so broad and works in so many different industries that it's impossible for us to really know every one of those plugins well. So we have Discord sub-channels for all sorts of different. We have one for the Tekla structures. We have one for Rhino inside Revit, where you can go and you can discuss Raven plus your plugin with other people using it, as well as with the developers, which is us, to tell us about features that you really need, things where you see Raven is breaking, where you want to push it further. So I really encourage you guys to join our Discord. You can find a link on our website. If you scroll down a little bit on the homepage of raven.build, and come in there and tell us what plugins you want. Then for the robots idea, I think that would be great. It would be super cool to integrate with or try programming an industrial robot arm. I used to program industrial robots arms with Grasshopper a lot back in my undergrad using KUKA PRC. So that would also be fun to integrate. Okay, so here we see, even though it's maybe a little bit of a node mess still, we can see we have all truss members ready, the support points ready, and the deck connections. Perfect. So this is exactly what we need to run our analysis with Karamba. So I will just select all these components because I want to cluster them. So now we have one cluster that constructs our arch. Of course, now Raven came and interfered with me. So it's really important that any edit that Raven makes, you can always undo it. So I will just click this button, which loads an earlier state of my script, and we're back to exactly what I want. This is the kind of setup that I need for simulation. It's still a fully parametric truss. So let's take it. I will copy it into, and save the file, into, you can see Raven realized that we're switching truss analysis. Yeah, I think truss analysis is good. Or actually, let's use the one that we had before, and I'm just going to clear out the data. Clear values, clear values, clear values, and clear values. So here we have the structural analysis script. Now I'm going to load in my new script. I will keep the chat. So I still have all this context history, even though I'm in a different file. And I will say, great, now connect up all the parameters into the Karamba truss analysis. And so let's send Raven off. I also realized that earlier when I was asking Raven to change the truss, I didn't even set it to the context profile. So information about Karamba, it doesn't either right now. So once we have this connection set up, Raven's doing some strange empty edit scripts. Okay, it's fine. No, that didn't work. You use the tool wrong. So Raven somehow thought he was connecting things, but it wasn't. So I'm just going to tell him it wasn't. There are some small features that I'm sometimes not sure if people are aware of them. One of them is the undo feature that we have on every edit, any change that Raven makes to your canvas. Another one is also that you can go back and you can change and rerun Raven on any of your prompts. So if Raven is not currently working, you can go back and you can change, for example, this prompt, or just like let Raven try again. So you can see now Raven's back out investigating the nodes that we have, zooming in and so on to figure out exactly how to wire them up, and then we can run our structural analysis on this truss. Also here we have this big cluster for the truss. You can make some Raven edits to the truss later as well and evaluate which one is maybe the most structurally sound and safe. It's like a very minimal one, like this. I was going to say earlier, but I got lost. If you introduce simulation plugins like Caramba into your parametric models, right? So Raven allows you to build parametrically from the start, so you don't have to go and sketch things out and try out 3D modeling in Rhino and then only go into a parametric model later. But instead, you can start parametric first and try out a lot more of different design options, explore the design space better. But the interesting part is when analysis comes in, you can then start to optimize. So you can not only check if this one truss is compliant or stiff enough, but you can try a whole wealth of trusses and make sure you find the optimal one that fits all of your requirements. Has enough height for pedestrians to pass through, is very lightweight, has a minimal amount of material needed, and that's where it gets really exciting. Okay. Raven's asked me to do some, actually, so I will show you this feature up here. You can go up here and you can just rerun something that Raven didn't do correctly. And it will reset the canvas state if there were any changes, which in our case there wasn't. It will remove the faulty thoughts and actions that Raven was doing from the context, and then just rerun it cleanly, which it's always a good idea. As soon as the LLM gets a little bit lost, it tends to spiral. So this way you can connect the context much better. Okay, so you can see Raven is immediately starting to edit. Also funny that it doesn't want to use the parameters that it created himself. That's okay, I'm gonna stop him, hook him up. Oops, I have a lot of sun on my face. And then there you go. Now it's hooked up to the, it looks great already. Okay, so let's ask Raven is this truss safe? Now that we have the Caramba analysis running? Max is gonna try to block the sun a little bit. I've connected up all your nodes in the Caramba. Yes, but now. Yes, but is the structure safe now? And then actually what I want to do is put Raven in the Caramba context profile and edit the beams and play with the beams a little bit. Maxi, let me know if there are ever any questions in the chat also. The maximum displacement across the entire structure is 1 centimeter. Okay, it's very rigid. I guess for 72 meters length, it's fine. You see though, it's a lot more displacement than we had before. Actually, I wonder what are the loads we are testing this with right now, because of course the displacement, it's nice to know the displacement, but it doesn't really mean anything if you don't know what loads you're simulating on the structure. And I'm actually not sure what we have set up, so I can just ask Raven. The truss is currently being tested with 3 load cases: live load, dead load. So live load would be when it's being used by pedestrians, dead load, and then lateral load. So we have a little bit of a wind force on it. Actually, you can see the load, we call it arrows, right here. We have the weight of the material. We have people standing on the deck that is being simulated, and then you can see which these flags here in red and blue show us which members are in tension and which are in compression. Now I'm actually going to activate the context profile. So far everything Raven's been doing even works without the context profile. And now I want to say, this is a work in progress context profile, but I want to say, can we try other kinds of beams? Because maybe we don't like this perfectly round cross section. And then also we can query Raven about the material that we're using. Maybe we want to change this to a timber structure. And because Raven has the specific Karamba context now, because it can look through all the nodes that we have, and because it can work on those semantics, it can be a really good co-pilot in switching around between different settings. And all of this is just using the normal Raven. If you have a lot of Karamba scripts already, or you know your way around, you can use a context profile, a private one, where you upload, for example, different material configurations that you use in your daily work, and then Raven can draw from those. So instead of using Raven to set up a timber material, you can have an existing timber material in your library of scripts, and Raven can draw from that. And that allows you to easily reconfigure and cycle through all of the scripts that you already have and that you know are reliable, with Raven just doing the reconfiguration. So that's also something that is super popular with things like Karamba, which have quite complex setups sometimes. Oh, you can see here, some of my Karamba components are outdated, but they still work. Raven still works with them, so that's also good. It's because the script that I'm using here to do the truss analysis is something that I found in my old scripts from years ago. Okay. Raven is preparing the file. I set up a new component to select cross-section from the standard library of Karamba. Okay, so we've switched to an IPE beam. There you see. So now we have I guess you call it an I-beam. Basic I-beam profile selected. And there's now a panel that we can use to pick any specific beam. So is there a W beam? That's pretty cool. Raven found this component that allows you to just use the name of any beams that Karamba knows, and because of the context profile, it knows, for example, that an IPE 200 is something that Karamba ships with, and so we can use that one directly. And actually, I think it got more rigid through switching the beam. Then now we switch to a W beam, I guess. Let me check. Yes, there we go. American Standard W section, white flange are included, and that's what we've just switched to. Great. So how is the displacement now? Let's see if this wider profile should obviously make it more the structure more rigid. And because it's still parametric, we can of course go in and as soon as Raven returns, I'll start playing with the parameters, and we get instant feedback. Actually, we can go to the end here and find, okay, 2 centimeters actually got higher. Because the beam, the structure slightly lighter, bringing the overall weight of the truss down. Okay, interesting. So the beam apparently is lighter and it is less rigid, but somewhere here there should be maximum. Actually, where can I find the maximum displacement? Because I'm curious if I change some of the parameters, whether the maximum displacement increases or decreases, and I can ask Raven to tell me where in the script I can find that info. Analyze component. So apparently there's a panel somewhere that should tell us this information, but I don't know where it is, so I'm just going to ask Raven to try. Actually, that's right here, huh? Displacement. There we go. I'm going to take this panel over to my parameters, and then we can see the live simulation. If we go from a frame count of 5 to 10, it should be much more rigid. Actually, it has a higher displacement. I'm assuming because of the weight of the material. So here we can go and see that actually, because we're using a heavy beam, the displacement is bigger if we have more. Actually, there some of the truss structures are more efficient than others. Okay. Yeah. This was very heavy on Karamba. I'm really sorry about our setup issues. Yeah, what can I say? We did not expect it to go this way, of course. When we were testing our live stream, it was all fine. But thank you for sticking with us anyway. And thank you for your inputs. Maybe we'll do a robot trial next time. That will definitely be even harder than running simulations like these. But what we really wanted to show you guys is the breadth of what Raven can do out of the box. So a lot of the Karamba stuff we're doing today is just Raven working through the nodes, having no specific Karamba information. But because Raven comes with a lot of intuition around structural engineering and so on, we can actually push it quite far. And then when we give it specific Karamba information, it can start to load in the right beam profiles and so on. The same is true with the Rhino inside Revit. We're building that extra context that Raven needs to be very good at helping you with your Revit workflows. And so if that's something that you're interested in and you want to support or you want to tell us where it breaks, come to our Discord and join that community. There's really like an active discourse there. So we can make that profile and make it work well for everyone. That was the RavenLive for today. Thanks for joining. I guess we will start doing this more often, just as a way to show you guys all the new cool things that we're building. Keep an eye out in the next couple of weeks. We have some bigger releases coming. I actually tease this in the YouTube live already, but I'm not going to do it. You'll have to wait till next week. But we have a webinar next Thursday that you can join. I hope to increase their Zoom capacity numbers because last time you guys signed up in the hundreds and McNeil was not prepared for it. But I will probably tease some of the scripting integrations that we're doing at Raven. So Raven doesn't only work with all of the plugins that you have and all of the native components, but it will start to integrate with Python C# nodes as well. So do I trust it if Raven says the structure is safe now? Yeah, absolutely. Okay, thanks for joining us. Really appreciate that you stuck around, and please go and try Raven. Send us an email, find us on LinkedIn, find us in the Discord, and we love to hear from you guys. And so we can build this tool for the Rhino and Grasshopper community together, make this all easier to use for all of you. Right, thank you. I'm going to end the stream. Max, you want to say bye?
Bye-bye, everyone.